In this video, we extend the work done on partial fractions. Let's first of all consider the fraction addition of 3 over x minus 2 plus 5 over x plus 1 plus 1 over x plus 7. To add these three fractions, we need a common denominator, and the common denominator we could use would be x minus 2 times by x plus 1 times by x plus 7. Now, 3 over x minus 2 is the same thing as 3 times by x plus 1, x plus 7 over the common denominator. Similarly, 5 over x plus 1 is the same thing as 5 times by x minus 2 times by x plus 7, all over the common denominator. And 1 over x plus 7 will be the same thing as 1 lot of x minus 2 times by x plus 1 over the common denominator. If we multiply out the brackets in each of these expressions, we get, first of all, 3 lots of x squared plus 8x plus 7, which gives me 3x squared plus 24x plus 21. In the middle term, we've got 5 lots of x minus 2 times x plus 7. Well, x minus 2 times x plus 7 gives me x squared plus 5x minus 14. Multiply that up by 5. I've got 5x squared plus 25x minus 70. X minus 2 times x plus 1 gives me x squared minus x minus 2. And then adding the three fractions up, we end up with 8x squared plus 48x minus 51. And this argument can be generalized to give us the following result. That if we've got something, a number over ax plus b, plus another number over cx plus d, plus another number over ex plus f, if we add those three fractions up, we'll get a fraction of the form px squared plus qx plus r over the common denominator of ax plus b times cx plus d times ex plus f. This means that we can reverse the process. So if we have a fraction of the form px squared plus qx plus r over ax plus b times cx plus d times ex plus f, we can rewrite it as a sum of partial fractions of the format a number over ax plus b plus another number over cx plus d plus another number over ex plus f. So let's see this in terms of an example. So if I wish to express 4x squared minus 2x plus 7 over x plus 2 times x minus 1 times 2x plus 1 as a sum of partial fractions, then I will start by saying that 4x squared minus 2x plus 7 over x plus 2, x minus 1, 2x plus 1 should be writable in the form a number over x plus 2 plus another number over x minus 1 plus another number over 2x plus 1. If we now multiply each side by the common denominator of the left-hand side, then the left-hand side will simply become 4x squared minus 2x plus 7. The right-hand side, we've got a over x plus 2 times by x plus 2, x minus 1, 2x plus 1. So for that part, the x plus 2's will cancel, and we get a times x minus 1, 2x plus 1. For the middle term on the right hand side, we've got b over x minus 1 times by x plus 2, x minus 1, 2x plus 1. The x minus 1's will cancel, so we're going to end up with b times by x plus 2, 2x plus 1. And then on the final term on the right hand side, we've got c over 2x plus 1 times by x plus 2, x minus 1, 2x plus 1. The 2x plus 1's will cancel, and we're going to have c times x plus 2, x minus 1. We want this to be correct for all values of x. And if it's going to be correct for all values of x, it's certainly got to be correct for x equals minus 2. Why did I choose x equals minus 2? Well, if I've got x equals minus 2, the last two terms on the right hand side will just give me 0. So putting x equals minus 2, the left hand side becomes 4 times minus 2 squared, which is 16, minus 2 times minus 2, which is plus 4, plus 7, so that is 27. On the right hand side, the first term becomes a times by minus 3 times by minus 3. So that becomes 9a. The second term is simply b times 0 times something. And the third term is c times 0 times something. So all we've got is 27 equals 9a. In other words, a must equal 3. If we now put x equals 1, then the first term on the right hand side will become 0, and the third term on the right hand side will become 0. So putting x equals 1, we've got the left hand side is now 4 times 1 squared, which is 4. Take away 2, add 7, so that gives me 9. The right hand side, when x equals 1, we've got a times nothing plus b times 3 times 3, so that is 9b, plus c times nothing. So what we've got is 9 equals b times 3 times 3. In other words, b must equal 1. Finally, if we put x equals minus a half in, then the first two terms on the right hand side will each become 0. If I have x equals minus a half, 4x squared is 4 times a quarter, which is 1. Take away 2 times minus a half is going to be plus 1, plus 7, so I get 9 equals, now with x equals minus a half, on the right hand side, the first term is 0, the second term is 0, and the final term is going to be c times by 1.5 times by minus 1.5, which gives me that c must be equal to minus 4. And this means that our partial fraction format for the original expression is 3 over x plus 2 plus 1 over x minus 1, take away 4 over 2x plus 1. Now let's move on and consider a different fraction addition. In this case we've got 3 over x minus 2 plus 5 over x plus 1 plus 1 over x plus 1 squared. With a little bit of thought, it should be clear that x minus 2 times by x plus 1 squared is the common denominator. So if we work with that as our common denominator, we can say that 3 over x minus 2 is going to be the same thing as 3 times by x plus 1 squared over the common denominator. 5 over x plus 1 is going to be the same thing as 5 times by x minus 2 times by x plus 1 over the common denominator. 1 over x plus 1 squared is just going to be 1 lot of x minus 2 over the common denominator. We know that x plus 1 squared is x squared plus 2x plus 1, so 3 lots of x plus 1 squared is going to be 3x squared plus 6x plus 3. We know that x minus 2 times x plus 1 is x squared minus x minus 2. So multiply that up by 5 for the middle term. We've got 5x squared minus 5x minus 10. And the x minus 2 we're quite happy with on the third term. And we can now add our three fractions up easily to obtain the single fraction 8x squared plus 2x minus 9 over x minus 2 times by x plus 1 squared. And of course this can also be generalized. If we've got an expression of the form a number over ax plus b plus a second number over cx plus d plus a third number over cx plus d squared, then that can be simplified down to a single fraction of the form a number times x squared plus another number times x plus a constant number, all divided by ax plus b times by cx plus d squared. And we can reverse this statement to say that if we've got a fraction of that format, px squared plus qx plus r over ax plus b times cx plus d squared, we should be able to rewrite it as a sum of partial fractions of the form a number over ax plus b plus another number over cx plus d plus then a third number over cx plus d squared. So let's have a look at this in terms of an example. So let's suppose we've got the fraction 7x squared plus 10x plus 1 over x plus 2 squared times by x minus 1, and we wish to write that as a sum of partial fractions. Well, we should be able to write it as something over the x plus 2. Now the x plus 2 is the repeated factor, so we're also going to have something over x plus 2 squared plus also something over the x minus 1. We now need to multiply through by the common denominator of x plus 2 squared, x minus 1. And if we do that, the left-hand side will simply become 7x squared plus 10x plus 1. If we multiply a divided by x plus 2 by x plus 2 squared, x minus 1, we are going to end up with a times by x plus 2 times by x minus 1. If we multiply b divided by x plus 2 squared by x plus 2 squared times x minus 1, The x plus 2 squareds will just knock each other out, and we're just going to end up with b times x minus 1. And if we multiply c divided by x minus 1 by x plus 2 squared times by x minus 1, the x minus 1's will just knock each other out, so I'm left with c times by x plus 2 squared. Now again, I'm going to go through, I want this to be true for all values of x, so I'm going to choose some fairly careful values of x, which will make the right hand side really simple to deal with. In particular, I could start off having x equals minus 2, because that will make the first term on the right hand side equal to 0, and it will also make the final term on the right hand side equal to 0. So if I put x equals minus 2, the left hand side becomes 7 times minus 2 squared, which gives me 28, plus 10 times minus 2, which is minus 20, add 1. So I've got 28, take away 20, add 1, that's 9. On the right hand side, when I put x equals minus 2, I've got 0a plus minus 3b plus 0c. So the only bit that comes in of any interest is the b times minus 3. So I've got 9 equals minus 3b, so b must be minus 3. If I put x equals 1 into our equation, then I'm going to get the first term on the right hand side equaling 0 and the second term on the right hand side equaling 0. So putting x equals 1, the left hand side is just 7 plus 10 plus 1, which is 18, equals 0 times a plus 0 times b plus c times 3 squared. In other words, 9c. And that tells me that c must equal 2. So I've already got the value of b and c. I still need to find out the value of a. Now at this point I just need to put in another easy value of x and a value that I haven't yet used for x. In this case, x equals 0 looks a nice easy one to do the arithmetic with, so I'm going to put x equals 0. And if I put x equals 0, then the left hand side is 0 plus 0 plus 1, which is simply 1. The right hand side, I've got a times 2 times by minus 1, so that's minus 2a. Then I've also got b times minus 1, which is minus b, and I've got c times by 2 squared, which is plus 4c. Now I know that b is minus 3, I know that c is 2, so this equation means that I've got 1 equals minus 2a plus 3 plus 8. In other words, I've got minus 10 equals minus 2a, so a must equal 5. And that means that our partial fraction form for 7x squared plus 10x plus 1 over x plus 2 squared x minus 1 is 5 over x plus 2 minus 3 over x plus 2 squared plus 2 over x minus 1. So we can now summarise our different partial fraction calculations in the screen that we've got here. And what I'd like you to try and do now is to work through these 5 examples. So as before, pause the video to answer these questions. Once you've answered the questions, if you restart the video, you'll obtain the answers. So there are the answers for the exercise that you've just been looking at. And this concludes our second video on partial fractions.